This is Dr. Heck, Consequences of Accidents in Industries. I'm looking here at tutorial problem 6.4. Assuming a complete reaction, determine the maximum temperature rise of a two-component reaction in an adiabatic batch reactor. And we're given some information here about the heat of reaction, the heat capacity, apparently the same for the entire mixture for both components, the molar mass of each component, and the amount of component 1 and 2. So I'd like to at least discuss with you the general approach for this problem. So starting out, the general idea here is that we have some heat change, so change in enthalpy, which is equal to here the amount of heat released due to, say, reaction. And so the way we can formulate this is the heat increase is mass times the heat capacity times the change in temperature. And this is equal to our heat of reaction times the amount of reaction. And so here it would be a lot better if you were given moles of reaction or some way to determine this. I don't particularly like how this problem is formulated, so I'm just going to call this N. So if we want to determine the heat, the temperature rise, then we can formulate that this is equal to the heat of reaction times the number of moles of reaction divided by the mass times the heat capacity. So what are each of these terms? The heat of reaction is 20,000 kilojoules per kilomole. The mass here, we can calculate, this is N1 is 100 kilomoles, and if we multiply this by the factor we're given of 180 kilograms per kilomole, we now have the number of kilograms of component 1. And repeating for component 2, we have 80 kilomoles of substance with 240 kilograms per kilomole, which is equal to this number of kilograms. So the only question here is what value of N was used. I don't think this necessarily makes sense, but if you take N1 plus N2, you get 180 kilomoles. And big M for the mass. And we also need to define this heat capacity is 1600 joules per kilogram Kelvin. If we do this, then we get this value given in the handbook of 60.5 Kelvin. So make sure you at least understand these equations and how you would calculate such a temperature rise. If I give you the problem, then I'd make sure that the reaction is described in a little bit more depth. Good luck.